Operators in C. The operators are represented by symbols which performs operations on one or more operands. The classification is given: arithmetic operators, logical operators, relational operators, increment and decrement operators, bitwise operators, assignment operators, conditional operators, and special operators. We will see each of the operators in detail. The arithmetic operators. These are used to perform arithmetic operations. Its type is binary, that is, it works on two operands. The operands must be numbers. These are the operators: plus for addition, example is 5 plus 2 equal to 7, minus, it is for subtraction, example 5 minus 2 equal to 3, star is for multiplication, 5 star 2 equal to 10, slash for division, 5 by 2 equal to 2. All these are integers. I am assuming it as integers, that's why the result is 2. If it is floating point, we will get the result as 2.5. Percentage, it is for modulus, that is remainder after division. So by 5% 2 will give a result equal to 1. It is a modulus after division, that is remainder after division of 5 by 2. Logical operators. These are used to perform logical operations. That is, it performs logical analysis of its operands and produces true or false result. That is, true represented by 1 and false represented by 0. Type: 2 ampersand symbols and 2 pipeline characters. These are binary type, that means works on 2 operands. The exclamation symbol, which is used for not, is a unary operator, that is, it works only on one operand. The operands can be Boolean values, that is, it can also be expressions or functions which results in Boolean value. The operators are 2 ampersand symbols representing logical AND operation. These are the logical AND operations: 0 and 0 equal to 0, 0 and 1 equal to 0, 1 and 0 equal to 0, 1 and 1 equal to 1. 2 pipeline characters stands for logical OR operation. These are the logical OR operations: 0 or 0 equal to 1, 0 or 1 equal to 1, 1 or 0 equal to 1, 1 or 1 equal to 0. NOT operation. NOT of 0 is 1 and NOT of 1 is 0. Relational operators. These are used to perform relational operations. That is, it checks the relation between two operands and returns the result as true or false. That is, the result will be 1 or 0. These are binary type of operators, that is, works on 2 operands. The operands must be numbers, or it can also be expressions or functions which result in a numeric value. These are the operators: less than, greater than, equal to. For equal to, we need to use 2 equal to symbols: less than or equal to, greater than or equal to, and not equal to. Examples are also given: 5 less than 2. This is not true, so result is 0. 5 greater than 2. result is correct. So answer is 1. 5 equal to 2. It is 5 is not equal to 2, so result is false or equal to 0. 5 less than or equal to 2. Result is correct, not correct, so result is equal to 0. 5 greater than or equal to 2. The result is correct and it will give a value 1. 5 not equal to 2. As 5 not equal to 2 is correct, the result is true. Increment and decrement operations. These are used for performing increment or decrement operations. Its type is unary, that is it will work on a single operand. The operands can be numeric variables or constants. It can also be expressions or functions returning a number. These are the operators plus plus and minus minus. Plus plus for increment and minus minus for decrement operation. For example, have initialized two values x is equal to 2 and y is equal to 5. After we perform plus plus x, the value of x will be incremented by 1. That is, the result is equal to 3. After performing minus minus 5, the value of y that is equal to 5 is decremented by 1. So result is 4. These operators can be used in two ways. That means can be prefixed or postfixed. Both have different meaning even though they perform the same operation. X plus plus is post increment, which returns the value of x first, then increments it by 1. That means if x value was initially 2, it returns the value of x itself. That is, during the execution it will return the value of x itself, but after the execution of the statement it will increment the value by 1. So after doing the statement, if we print the value of x, it will be equal to 3, but during the operation it is returning only the same value of x. Next is plus xx, which is pre-increment operation, which returns the value of x incremented by 1. That means if x was 2 initially, it will return the incremented value itself. That means it will return 3. Next is y minus minus, which is post decrement operation, which returns the value of y first, then decrements it by 1. That means if y was 5 initially, it returns 5 itself and then it decrements the value of y by 1. So after the execution of this statement, if we try to print y, the value will be equal to 4. Next is minus minus y, which is pre-increment operation, which returns the value of y decremented by 1. That is, if y was equal to 5 initially, it returns as well as decrements the value by 1. It returns the value decremented by 1. That is equal to 4. Bitwise operators. These are used for performing bitwise operations. Type of these bitwise operators are binary. It is ampersand, pipeline, less than, greater than, and cap or caret are binary. It works on 2 operands. The tilde character is unary operator. It works on a single operand. The operands must be numbers, or it can also be expressions or functions which result in a numeric value. These are the operators: ampersand for bitwise AND, pipeline for bitwise OR, tilde for bitwise ones complement, caret for bitwise XOR, greater than for bitwise right shift, less than for bitwise left shift operation. Some of the examples are 5 and 2 equal to 0. It is detailed here. Five and 2 operation. To perform this operation, we will write the corresponding binary number. The bitwise representation of 5 and 2. This is 5, 101, and 10 is 2. So the bitwise AND operation is done. 1 and 0 equal to 0, 0 and 1 equal to 0, 1 and 0 equal to 0. So the result is 0. Second operation, 5 or 2. The result is 7. The bitwise OR operation is described here. 5 and 2 bitwise operation. 1 or 0 equal to 1, 0 or 1 equal to 1, 1 or 0 equal to 1. So the result is 7. Third operation, bitwise ones complement operation. Ones complement of 5, bitwise ones complement operation of 5 result in -6. This is 5 written in binary as a byte, that is 8 bits. Its ones complement form is written here, that is everything is complemented. 1 is complemented 0, 0 complement 1, 1 complement 0, 0 complement 1, 0 complement 1, 0 complement 1, 0 complement 1, and 0 complement 1. So it is actually the 2's complement form, and the result is -6. In 2's complement form, the result is actually -6. Next is bitwise XOR operation. 5 XOR 2. So it is performing bitwise XOR operation. 1 XOR 0 is 1, 0 XOR 1 is 1, 1 XOR 0 is 1, and here all these cases 0 XOR 0 equal to 0, and so the result is equal to 7. This is a right shift operation. 5 right shift by 2 positions. The result is 1 like this. We are shifting this number to 2 positions right. If you shift 2 positions to the right, the 0 and 1 will be neglected. That means when it is right shifted, we can put 2 zeros before that. That means the result will be equal to this much, and the last 2 numbers will be omitted. This is the result equal to 1. Last operation, bitwise left shift operation. So it is shifting 5 to the left by 2 positions. So all the bits will be shifted to left 2 positions. So if everything is shifted to 2 positions left, the last 2 zeros will be neglected. That means 2 zeros will be attached here. It is moving to the left, that means this much portion represents this area, and 2 zeros will be attached at the right side, and this is 20. So result is equal to 20. Assignment operator. Assignment operators are used to assign values to a variable. These are used to assign values to the variables. These are binary type, that means it works on 2 operands. The operands must be numbers or something that returns a number. So these are the example, these are the operators, and for all these operations we have some examples also, and for these examples let x is equal to 5 initially. For all these examples we will consider x is equal to 5 initially. First one is equal to, which is the equal to operator, it assigns the value from right to left. That means in these examples 2 is assigned to the variable x. The meaning is written here, x is equal to 2. That means 2 is assigned to x. It returns the result, that is assigned value equal to 2. Next is plus equal to, which is add and assign. X plus equal to 2, the meaning is x is equal to x plus 2. So the initial value we are assuming as 5, so it is equal to 5 plus 2, the result 7. Subtract and assign. It is x minus equal to 2. The meaning is x is equal to x minus 2. So 5 minus 2 equal to 3, the result. Star equal to, which is multiply and assign. Example is x star equal to, x is equal to x star 2 equal to 5 star 2 equal to 10. Slash equal to, which is divide and assign. X slash equal to 2, x is equal to x slash 2 equal to 5 slash 2. The result is 2. We are assuming it as integer, so the result is 2. 5 by 2 equal to 2. Percentage equal to, which is modulus operation and assign. X percentage equal to 2 means x is equal to x percentage 2. That is 5 percentage 2 will be assigned to x. 5 percentage 2 is the modulus after division is, the remainder after division is 1. And equal to, that is bitwise AND operation and assign. X and equal to 2 means x is equal to x and 2 equal to 5 and 2 equal to 0. It performs the bitwise AND operation. So bitwise AND operation is bitwise operations are detailed in the previous video. If you want to check, you can check the previous video to understand all the bitwise operations. Or equal to, bitwise OR function and assign. X OR equal to 2 means x is equal to x OR 2 equal to 5 OR 2 equal to 7. All these are bitwise operations. Bitwise XOR operation and assign. X OR equal to 2 means x is equal to x OR 2 equal to 5 or 5 XOR 2 equal to 7. All these are XOR operations. Bitwise shift left and assign operation. That means for x less than equal to 2, that is x left shift 2 will assign the left shifted value of x to x. That is 5 less than 2, that is 5 left shift 2 will be assigned to x. The result is 20. Bitwise shift right and assign. X right shift equal to 2, which assigns the right shifted value of x to x. The result is 1. Conditional operators. It can be used instead of an if-else statement to perform operations based on a particular condition. It is a ternary operator which works on 3 operands. This is the method in which we use the conditional operator. There are 2 methods, method 1 and method 2. I'll explain the first method, and for these examples I am taking the variables x is equal to 5 and y is equal to 2 initially. So expression 1 question mark, expression 2 colon, expression 3. The meaning is if expression 1 is true, expression 2 is executed. If expression 1 is false, expression 3 is executed. I'll explain once again. If expression 1 is true, expression 2 is executed. If expression 1 is false, expression 3 is executed. So our operator part is only this question mark and this colon symbol. These 3 are 3 expressions. The example is this: x less than y question mark, printf %d comma x colon, printf %d y. Meaning is it will check this condition, x less than y. If it is true, it will execute the second statement, second expression. If it is false, it will execute the third expression. So here in this example, x value is 5 and y value is 2. So what happens is x less than y, that is 5 less than 2, returns 0, that is it is false. That means it will execute the third expression. The third expression is printf %d comma y. That means the value of y, that is equal to 2, is the result. This is a method 2, variable equal to expression question mark value 1 colon value 2. Here the meaning is if expression is true, value 1 is assigned to variable. If expression is true, if this expression is true, value 1 will be assigned to variable. If the expression is false, value 2 will be assigned to variable. If the expression is false, value 2 will be assigned to variable. Here in the example, z is equal to x not equal to y question mark, x plus 100, x minus 100. This is the condition, x not equal to y. So this condition is actually true because 5 is not equal to 2. So this is true. True means what happens? The value of x plus 100, that is value 1, will be assigned to x. X is initially 5, so 5 plus 100 equal to 105 will be assigned to z. Special operators. These are the operators which are used to perform some special operations. The first one is comma operator. It returns the right side operand value. Both operands can be expressions resulting in a value. Both expressions will be executed, but result of first expression is discarded. Result of the first expression will be discarded. That means in this example, x is equal to 5 plus 2 comma plus x. The result of the first expression will be discarded. Both will be executed, but the result of first expression will be discarded, and the result of second expression will be stored in x. That means the result will be equal to plus x. Plus x value is plus 5, that is equal to 6. Next, the size of operator. Size of operator, which is used for finding out the size of a data type or a memory location. If we write size of char, it will return 1 because the size of a character is 1 byte. Size of C, here C is declared as a character type, so size of C have the same meaning of size of char, so it will also return 1. Next is size of x. X is an integer type, so the result will be equal to 4. That means 4 bytes are used for storing an integer variable. Next operator is AND operator. AND operator is also used for accessing the address of a memory location. Ampersand x will return the address of x. The x equal to x is having a value equal to 5, and ampersand x will return the address of the location where 5 is stored. Last one is star operator, which is a pointer, and the pointer is used like this, star p. It makes the variable p a pointer variable. Pointers are used for storing the address of a memory location. That means after we declare a variable p as a pointer, this is a declaration in the star p. We can assign some integer variable address to be stored in p. That means after writing this, we may write p is equal to ampersand x, which stores the address of 5 to p.